Welcome to viewers. Here we will discuss again solution of linear simultaneous equations. Earlier we discussed method of substitution and method of elimination. Now let's start with method of cross multiplications for solving linear simultaneous equations in two variables. So equation 1 is a1x plus b1y plus c1 equal to 0. a2x plus b2y plus c2 equal to 0. Now we will derive the formula for solving simultaneous equations by cross multiplication method. We will take the help of method of substitution that we discussed earlier. So equation 1 here implies that a1x equal to minus b1y minus c1. So what is x? Minus b1 by a1y minus c1 by a1. That means we find x in terms of y from equation 1. Now substituting this value, of x in equation 2, we are substituting this value of x in equation 2. So what will you get? a2x, x means minus b1 by a1y minus c1 by a1, a2x plus b2y plus c2 equal to 0. So let us simplify this. Minus a2b1 by a1y minus a2c1 by a1 plus b2y plus c2 equal to 0. Now to eliminate this fraction here, we will multiply both sides of this equation by a1. So if you multiply both sides by a1, a2b1y divided by a1 into a1 minus a2c1 by a1 into a1 plus b2a1y plus c2a1 equal to 0. Now this a1 cancel each other. So you can do more simplification now. Let us combine the variable part first. a1 b2y minus a2 b1y equal to, we will transpose the term not containing variable to the right hand side. So you will get a2c1 minus a1c2. Let us take y common. a1 b2 minus a2 b1 equal to a2 c1 minus a1 c2. So what is y here? a2 c1 minus a1 c2 divided by a1 b2 minus a2 b1. You can write it as a2 c1 minus a1 c2 multiplied by 1 by a1 b2 minus a2 b1 equal to a2 c1 minus a1 c2 multiplied by k, where k equal to 1 by a1 b2 minus a2 b1. Suppose we are assuming that this part is say k, so this becomes a2 c1 a1 c2 multiplied by k. So you got y equal to this. Therefore you can write it as y divided by a2 c1 minus a1 c2 equal to k, right? From this you can write it as y divided by a2 c1 minus a1 c2 equal to k. Now we got the value of y by solving this linear equation. Now we can substitute this value of y in equation this to find the value of x. So we will find value of x. What is x? X equal to minus b1 by a1 into y. Y means this, a2 c1 a1 c2 divided by a1 b2 minus a2 b1. So x equal to minus b1 by a1 into y minus b1 by 1 into y minus c1 by a1, c1 by a1, right? So let us simplify this. The LCM will be a1 into a1 b2 minus a2 b1, right? Product of LCM of this and this is this. Since this is a multiple of this denominator is a multiple of denominator of c1, so LCM will be this. Now you find the numerator as b1 into a2 c1 minus a1 c2 minus c1 into a1 b2 minus a2 b1, right? Now you simplify this. a1 into a1 b2 minus a2 b1. Let us simplify this. Minus b1 a2 c1 plus minus minus plus a1 b1 c2 minus multiplication of this is a1 b2 c1 minus minus plus a2 b1 c1. Now you see a1 b1 c2. Can we cancel any of these terms? b1 a2 c1, b1 a2 c1. So this is negative, this is positive, cancel each other. So on simplification we got a1 multiplied by b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1. So this a1 cancel each other. We can write it as b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1. This again you can write it as b1 1 by a1 b2 a2 b1 multiplied by b1 c2 minus b2 c1. So this you can write it as b1 c2 b2 c1 multiplied by k, right? So the same way we did earlier, we can write it as x divided by b1 c2 minus b2 c1 equal to k. So we got y equal to y by a1 c2 a2 c a1 a2 c1 minus a1 c2 equal to k. Here we got x by b1 c2 minus b2 c1 equal to k. So combining this together, we can write it as x divided by b1 c2 minus b2 c1 equal to y divided by a2 c1 minus a1 c2 equal to k. K means what is k? 1 by a1 b2 minus a2 b1, right? We got that y divided by a2 c1 a1 c2 equal to k. This is equal to k. X divided by b1 c2 minus b2 c1 equal to k. So both are equal to k. So we can write it as x by b1 c2 minus b2 c1, y by a2 c1 minus a1 c2 equal to k. K means 1 by a1 b2 minus a2 b1. Now from this relationship we can solve the values of x and y. Let us try to do this, right? What we got? X by b1 c2 minus b2 c1, y divided by a2 c1 minus a1 c2 equal to 1 by a1 b2 minus a2 b1. So we can solve the values of x and y from this relation. Now let us compare this with this. X by b1 c2 minus b2 c1 equal to 1 by a1 b2 minus a2 b1, x equal to b1 c2 minus b2 c1 by a1 b2 minus a2 b1. Similarly, you can solve y here. Y equal to a2 c1 minus a1 c2 a1 b2 minus a2 b1. These are the solutions of the pair of linear equations in standard form. Now, in both cases, you see denominators are same, a1 b2 a2 b1. In the case of y also, this is a1 b2 minus a2 b1. Only numerators are different. So how will you remember this formula? So once again you recall the equation, y a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Now let us try to write the coefficients like this, a1 b1 c1. In the second equation, coefficients are a2 b2 c2. Now to find the numerator of x, we will try to find the numerator of x, y and 1, means this. Okay, so for finding the denominator of x, what will you do? You hide this part, then you cross multiply this b1 c2 and b2 c1. So for finding the denominator of x, we will cross multiply this b1 c2 minus b2 c1. Then you find the denominator of y. We will hide the coefficients of y. Now you will multiply, this time you multiply from this side. Red line indicates this will be done first, and blue line indicates this will be done second. So finding denominator of y, we will hide the coefficients of y. Now a2 c1 minus a1 c2. Then you find the denominator of the constant. Again you hide the coefficients of constant term, or you hide the constant terms. Now let us multiply from this side first, and this is second. So a1 b2 minus a2 b1, right? So when you find the denominator of x, you hide the coefficients of x, you multiply this b1 c2 b2 c1. This red line indicates we are doing this one first. When you find the denominator of y, you hide the coefficients of y. This time we are multiplying from this bottom side, a2 c1 minus a1 c2. When you are finding the denominator of 1, you hide this. Again you are multiplying from top side, top to bottom. Red line indicates first a1 b2 a2 b1. That is how you can remember the theorem formula. Now let us try to solve two pair of linear simultaneous equations with the help of cross multiplication. So example, suppose let us see 4x plus 3y equal to say 17, and 3x minus 4y equal to say minus 6. Now let us convert this equation into standard form first. Solution. You are given 4x plus 3y equal to 17. That means 4x plus 3y minus 17 equal to 0. This is equation 1. Similarly, second equation is 3x minus 4y equal to minus 6. this implies 3x minus 4y plus 6 equal to 0. This is equation 2. Now let us try to solve this by method of cross multiplication now. So let us try to write the coefficients first. 4, 3 minus 17. Coefficients of x 4, y is 3 and constant term is minus 17. In the second equation, 3 minus 4, 6, right? So by cross multiplication we will write here x, y and 1. Now in case of y, you will hide the coefficients of, in case of x, if you will hide the coefficients of x, so you do cross multiplication here, starting from, say, blue line indicate first one, 3 into 6 minus, suppose red line indicates second, minus 4 into minus 17. Now for finding the denominator of y, you will hide the coefficients of y. Here you will start from the bottom. So blue line indicates suppose first and red line indicates second. You hide the coefficients of y. So you first multiply 3 into minus 17. 3 into minus 17 minus 4 into 6. Now you find the denominator of y. So you hide the constant terms. Here you again first do from the top to bottom. This blue line indicates first, red indicates second. So you multiply 4 into minus 4 minus 3 into 3. So let us simplify this. X divided by 18, then minus 68 equal to y divided by minus 51 minus 24, 1 divided by minus 16 minus 9. Further simplification you got x equal to x by minus 50, y divided by this becomes minus 75, 1 divided by this becomes minus 25. Therefore x by minus 50 equal to 1 by minus 25. If you cross multiply this, minus 25x equal to minus 50, that means x equal to 2. So you try to compare this and this. Y by minus 75 equal to 1 by minus 25. So y equal to minus 75 divided by minus 25 equal to 3. So our solutions are x equal to 2, y equal to 3. Right? This is how you can solve a pair of linear simultaneous equations by the method of cross multiplication. Right? Now let us try to do one more example with the help of method of cross multiplication. Say you are given two equations. Example 2. Suppose 4x minus 3y minus 11 equal to 0. This is suppose equation 1. And another equation is 6x plus 7y minus 5 equal to 0. This is equation 2. Now you try to write the coefficients first. 4 minus 3 minus 11, 6, 7 minus 5. Right? Now by method of cross multiplication, we get x divided by y divided by 1 divided by x by, now you hide the coefficients of x. When you find denominator of x, you hide the coefficients of x, then you cross multiply this, minus 3 into minus 5 minus 7 into minus 11. Then you find the denominator of y, hide the coefficients of y. Here you multiply from bottom side, 6 into minus 11 minus 4 into minus 5. When you find the denominator of y, you hide the constant terms. Now you multiply from top side, 4 into 7 minus 6 into minus 3. So let us simplify this. This implies x by 15 plus 77, y divided by minus 66 plus 20 equal to 1 divided by 28 plus 18. Further simplification, you can get 7 plus 5, 2, 8 to 7 plus 1, 8, 9, x by 92. Y divided by, this becomes 6 minus 0, 6, 6 minus 2, 4, minus 46. 1 divided by 8 plus 8, 16, 6, 1 over 2 plus 1, 3 plus 4. So x by 92 equal to 1 by 46. That means 46, x equal to 92, x equal to 92 by 46 equal to 2. And y by minus 46 equal to 1 by 46. This implies 46, y equal to minus 46, y equal to minus 1. Therefore, solutions are x equal to 2, y equal to minus 1. This is the answer, right? Viewers, thank you for watching. We will discuss similar examples in the next class. Bye bye.